SpaceX ignites the stars. A TikTok-inspired laser welds Starship steel, Alloy 30X redefines strength, and Raptor 3's 3D printing rewrites rocket science. Can a social media spark save Mars? Join Starship mission updates. Let's dive in. When SpaceX first envisioned Starship, they weren't planning to use steel at all. Elon Musk was betting everything on carbon fiber, the same lightweight material found in high-end sports cars and racing bikes. At just 1/5 the weight of steel, carbon fiber promised a spacecraft that could carry more payload with less fuel. SpaceX had already invested millions in massive carbon fiber mandrels and manufacturing equipment, but there was a fatal flaw. Carbon fiber starts breaking down at just 200 degrees Celsius. During re-entry, Starship would face temperatures of 1,600 degrees Celsius. This would require such a thick heat shield that it would negate the weight savings. Plus, at $150 per kilogram versus steel's $3, carbon fiber would make each Starship cost prohibitive. The decision to switch to stainless steel wasn't just a small design change. It was a complete manufacturing revolution that would make or break the entire Mars mission. Here's where things get dramatic. The first stainless steel prototype, affectionately nicknamed the Water Tower or Giant Soda Can by critics, was built outdoors in the harsh winds of Boca Chica using flux core arc welding. This dual-shield welding process works by feeding a tubular wire filled with flux while using external shielding gas. But stainless steel fights back when you weld it. Unlike other metals, it retains heat stubbornly and expands more when hot. This creates what engineers call the heat-affected zone, or HAZ, a weakened area around each weld that becomes more vulnerable to corrosion and structural failure. The result? On November 20th, 2019, the Mark I prototype catastrophically failed during pressure testing. The welds gave way, sending the bulkhead flying through the air. Millions of dollars and months of work destroyed in seconds. This wasn't just embarrassing. It threatened the entire Starship program. NASA was watching, investors were watching, and Elon's timeline for reaching Mars was slipping away with each failed test. How do you solve a problem that could sink your entire company? You innovate or die. After the explosion, SpaceX made a crucial switch to tip-TIG welding. What's the difference? Imagine traditional welding as hammering two pieces of metal together, while tip-TIG is more like gently stirring them until they become one. The secret is in the vibration. Tip-TIG adds a vibratory motion to the welding wire, making the molten metal more fluid. This helps release trapped gases and impurities, resulting in stronger, cleaner welds. The process also applies hot wire current to the filler metal before it enters the weld pool, essentially preheating it for better fusion. The results were immediate and dramatic. Elon Musk himself confirmed the impact in a tweet. Switching from flux core to tip-TIG welding improved accuracy, created stronger welds, and reduced overall weight by up to 20%. But could humans achieve the perfect consistency needed for a spacecraft that would someday carry people to Mars? As Starship evolved, SpaceX realized that even the steadiest human hand couldn't match the precision needed for perfect welds. They began investing heavily in robotic welding machines from companies like Liberty and KUKA, specialized robots that never get tired, never have a bad day, and can reproduce the exact same weld thousands of times. This wasn't just about consistency. It was about speed. Elon's vision called for building thousands of Starships to create a sustainable colony on Mars. No team of human welders could possibly keep up with that pace. But the real revolution was still to come. Here's where the story takes an unexpected turn that nobody saw coming. In 2023, Rex Alexander, SpaceX's senior welding engineer, received a strange package from Elon Musk. A handheld laser welder that Elon had spotted in a TikTok video and ordered from Amazon on a whim. Alexander was initially skeptical. A handheld laser welder for building spacecraft? It seemed ridiculous. But he began experimenting with it anyway, and something extraordinary happened. The laser created welds so clean and precise that they started using it on actual flight hardware. What began as a TikTok-inspired experiment soon expanded from structural components to the nose cone and eventually to many sections of Starship. Why? Because laser welding allows for incredibly precise heat application and deeper penetration into the metal, making it possible to join thick steel rings in a single pass. Think about that. One of the most advanced spacecraft ever built is using technology that Elon discovered while scrolling through social media. Could any other aerospace company operate this way? While perfecting their welding techniques, SpaceX was simultaneously developing something even more revolutionary: their own custom steel alloy. The journey began with Type 301 stainless steel, which offered excellent formability in its annealed state and high strength when cold worked. But there was a problem. At the cryogenic temperatures of liquid oxygen and methane, the welds became brittle. SpaceX then switched to 304L stainless steel, which maintains superior toughness at extremely low temperatures. As Elon Musk explained, at cryogenic temperatures, 304L is over 4 times stronger than 301, crucial for tanks holding supercold propellants. But the real game changer came with the development of Alloy 30X, SpaceX's proprietary steel formula. While the exact composition remains a closely guarded secret, its appearance on the newest Starship Block 3 suggests capabilities far beyond off-the-shelf metals. This raises a fascinating question. Is SpaceX now more of a material science company than a rocket company? Take a look at Starship 39's nose cone, the first of the Block 3 series. Notice how impossibly smooth and clean it looks. That's not just for aesthetics. SpaceX uses a process called planishing, essentially hammering and compressing the welds until they match the hardness and uniformity of the surrounding metal. This not only reinforces the structural integrity, but also creates that mirror-like finish that has become Starship's signature look. The evolution of SpaceX's Raptor engine isn't just a story of technological advancement. It's a manufacturing revolution happening right before our eyes, a revolution that left NASA engineers speechless. Let's unpack how SpaceX is achieving what many industry experts thought impossible. SpaceX's McGregor facility in Texas recently welcomed Raptor 3 engine number 20, just weeks after number 16 arrived for testing. This might not sound remarkable until you consider the timeline. SpaceX has built these 20 next-generation engines in just 9 months since the first one appeared in August 2024. But here's where it gets interesting. Raptor 2 production peaked at over 1 engine per day back in November 2022. This allowed SpaceX to stockpile more than 200 engines in under a year. So why is Raptor 3 production slower at only 2 to 4 engines monthly? The answer reveals the first paradox. Raptor 3's simplified design actually makes it more difficult to manufacture. How can something simpler be harder to build? Because simple in appearance doesn't mean simple in execution. When engineers say Raptor 3 is simplified, they're referring to its integration of components that previously existed as separate parts. Each Raptor 3 delivers a staggering 280 tons of thrust, 50 tons more than Raptor 2, while simultaneously reducing weight to just 1,525 kilograms. Even more impressive, the engine eliminates the need for an external heat shield through integrated cooling systems. Think about that. More power, less weight, fewer parts. It's like building a car engine that's twice as powerful, half the weight, with no radiator because cooling is somehow built directly into the block itself. But how is this physically possible? What manufacturing technique could possibly create such complex integrated structures? The secret, Elon Musk's hidden solution that NASA couldn't believe, lies in SpaceX's advanced implementation of additive manufacturing, or what we commonly call 3D printing. But forget everything you think you know about 3D printing. SpaceX isn't using the plastic layer-by-layer process you might be familiar with. They're pioneering metal 3D printing at an industrial scale never before achieved. Traditional rocket engine manufacturing involves machining, starting with metal blocks and cutting away material until you get the shape you want. Imagine sculpting by removing marble to create a statue. It's wasteful, time-consuming, and limits what you can build. Now imagine if Michelangelo could have created a sculpture by adding material only exactly where needed, with the ability to build hollow internal structures and complex patterns impossible to chisel. That's what SpaceX is doing with metal. But how exactly does this transform rocket engine production? Consider one of the most critical components of any rocket engine: the turbo pump. This device must handle incredibly high-pressure flow of cryogenic methane and oxygen propellants. Traditionally, these pumps require dozens of separate parts welded or bolted together, with each connection point representing a potential failure. This is your mission update team with Starship mission. Updates! From TikTok-inspired welds to Raptor 3's 3D printed marvels, we're witnessing humanity's path to Mars. Thank you for tuning in. Like, subscribe, and keep looking up. Curiosity and innovation will guide us to the stars. What's next for SpaceX's revolution? Share your predictions below.